All right, and so this starts pardon the bad pun, a series of videos to help us out with discrete mathematics. So with discrete mathematics, we're going to be talking about arithmetic sequences and a little bit later geometric sequences and then arithmetic and geometric series as well. So this video is on specifically arithmetic sequences. Now, what is an arithmetic sequence? Well, it's a numbered list of terms with a defined starting point. It's a very important part. And we actually define our starting point as the first number, and we specifically call it U sub 1, or just U1, meaning this is the first unit in our series. In our sequence. I'm going to missay series and sequence often. I apologize in advance. Where the terms are related by a common difference. Now, a common difference is slightly different than a starting point. A common difference is the amount required to move from one term to the next. And you can see that at every single point, to move from one term to the next, all I have to do each time is add 3. So we would say that D, our common difference, is 3. So then, toward the end, we would come up with a general term. Now, a general term is a way to describe any one of these terms by their position in the list. So we say that U1 is in the first position. We say that U2 is in the second position. U3 is in the third position. We would have a little bit of work to figure out which numbers these are. But a little bit later on, we'll come to UN, and this would be the nth term. So the first, second, third, fourth, fifth, sixth, seventh, all the way up to the nth term. Now, to find the nth term, we have a formula, and this is in your data booklet. We take the first term, and then we add the common difference times 1 less than the number of terms we're looking for. So this says, okay, start at U1 and then add D n minus 1 times. So to get to U2, we start at U1 and then we add D 2 minus 1 or 1 time. To get to this one, we would start at U1 and then we would add D, looks like a whole bunch of times. It's actually 11 times, which would mean that adding D 11 times tells me this is probably the 12th term. Well, let's find that out. Now, the way that we find out, hey, what term has 37 as UN? So when you're wondering what term something is, you're talking about finding n. And that means find n if it's the first, second, third, or whatever term. Now, a lot of times you're going to want to just go ahead and use logic and start counting up by 3s. And I'm going to strongly suggest that you don't do that, as you can do this much more quickly by starting with your general term, substituting and doing a little bit of quick algebra. So let's do that. So our general term is UN is equal to, now instead of writing U1, I'm going to use U1 from over here. So 4, because we're talking about this specific sequence. I told you I was going to do that. Plus my common difference. Now, my common difference is, to go from there to there, 3. And then this is times n minus 1. Now, I want to solve for n if UN is 37. So I'll have 37 equals 4 plus 3 times n minus 1. And instead of doing trial and error, I can subtract 4, then I can divide by 3, and then I can add 1, and I can say that, hey, 37 is the 12th term, or U12 is equal to 37. So that would mean that this would be the 13th term, this would be the 14th term, and so on and so forth. Now, there is one other thing that's important to show. You're not always given the starting point. In fact, sometimes you're given a few things and told how many terms are in the sequence and given an end point. You have to work backwards. There's lots of different ways to give it. But there is a good formula that's useful for D. So where we have this formula for our general term, it's also important to have another formula for D. So I'll do that formula here, and this is for the common difference. And this is going to take advantage of a little bit of subscript. So D is equal to UN minus UN minus 1. Now, this says it's equal to a term minus the term before it. So it's equal to 43 minus 40, 3, or 40 minus 37, 3, or 13 minus 10, 3. It doesn't matter which term you pick, just as long as you subtract the one before, it should always be the same thing. And that's useful when you're justifying whether or not something is an arithmetic sequence or series, because you'll need to show that there's a common difference everywhere to show that it is such. And that's arithmetic sequences.